Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4. And then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 3/20. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them, and let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here, and we know that this angle here will also be 85 degrees because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles, and we know that this angle here is going to be 180 degrees because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an X and this a Y and written X equals 85 and Y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table. And we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40. And we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80. And the frequency is how high it is, which is 10. The next midpoint is here. So that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160, so that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So angles on a point add up to 360. And we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together. And so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. So this question is a simultaneous equations question, and so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80, or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8a. And so we're going to times the 2a by 8, which will be 16a plus 24p. And 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2,340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get a equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write out. Instead of a, we know that a is a pound, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So that's going to be 780. So we know that we've got it right. First thing we notice is that there is a square here. So we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of 2 shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these 3 here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square take away the circle. So 1,600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here. And this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked two activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got X plus 2X, which is 3X. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. So we've got to get the left-hand side factorised. So we put down 2 sets of brackets. And we're looking for 2 numbers that multiply together to make that 24 and add together to make the 14. And we're going to have an x at the start of each of those brackets. So 24 would be 12 and 2 would add together to make 14. So plus 12 plus 2. And to solve, we get the left-hand bracket equal to 0. And we get our solving lines in. So minus 12 both sides. And you get x equals minus 12. So that's one of our solutions. And we do exactly the same thing with the other bracket. Get it equal to 0. And solve. So we're going to take away 2 from both sides to get x on its own. So x equals minus 2. So our solutions are 12 and minus 2. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. In this question we have a right angle triangle, and we know 2 of the sides, and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So here we're asked for a minus b. So in our vector we're going to do a, which at the top is 5, take away b, which at the top is 4. And we're going to do the same with the bottom. So we're going to take away the minus 2, we're going to take away the 7. 5 take away 4 is going to be 1. Minus 2 minus 7 is going to be minus 9. So our vector will be 1 at the top and minus 9 at the bottom. We know that vectors are written as the amount right at the top and the amount up we go at the bottom. So looking just at the x coordinates, we've gone from 5 to 7, so we've gone right 2. Looking at the y coordinates, we've gone from 6 down to 2, so we've actually gone down 4, so it's going to be minus 4. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. I'm going to first of all get x equal to the 0.151151, blah, blah, blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000, and we'll get 151.151.151, blah, blah, blah. What we're going to do now is we're going to subtract going downwards. So 1000x take away x would be 999x, and then 151.151.151, etc. Take away 0.151.151, etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. So with any curve, when we do the graph, we want as many x coordinates as possible. And here we're given a table to use. So we're going to start off by doing 11 to the power of minus 0, so this one here. And 11 to the power of minus 0 is just the same as 11 to the power of 0, and anything to the power of 0 is 1. So this will be 1. And we're going to go left, so we're going to do x to the power of minus 1. Well, two minuses make a plus, so x to the power of 1 is just 11 to the power of 1 is just 11. And same with this. Minus and a minus make a plus, so it's just 11 squared, which is 121. So we've got 11 and 121. Now, when we have 11 to the power of minus 1, we know a negative just puts a 1 over it. So it's 1 over 11 to the power of 1, which is just 1 over 11. So this will be 1 over 11. And then, similarly, minus 2 to the power of minus 2 would just be 1 over 11 squared, which would be 1 over 121. So when we plot this, and this is not easy to plot, but all of these ones here are going to be really low down. And I might use a different colour just so they show up a bit more, but these are just going to be so low down. And this is the problem with plotting exponential graphs, is that they get very big and very small very quickly. Then we've got this next one's at 11, so roughly there. And then we've got 121, which is roughly there. And for these kind of graphs, they are very forgiving in the exam. And so we just need a smooth line to join them up. And this is the part here that is not easy to do. Something like that. Now in the exam, that looks not great, but I just want to show you that actually that would still get the mark on the exam. They're not marking you on artistic talent. They're just making sure that you've got a smooth line with no gaps, no feathering like this, just connecting the points. It's a little bit wavy, especially down here, but you tend to they tend to be quite forgiving. Now, a bit of a recommendation, especially for exponentials, like the one we've got here, is it really helps to turn your page sideways when you do it, and it just gives you a bit more vision and just makes it a bit easier to draw those curves. So looking at the graph straight away, we know that the y-coordinate of point A is 0, and we're told that it's y equals tan x, and you just need to know the graph y equals tan x, and if you know the graph, we know that that will be 180 degrees. We know the point at which both of these lines will be going towards would be 90. This point here will be 270, and so therefore this point will be 360 degrees. So it's going to be 360, 0. So to be able to solve this, we want to factorise the quadratic. And to factorise the quadratic, we're going to look at the coefficient x squared and the number left on its own, and we're going to multiply those together. So that we're looking at two numbers that equal, what is it, 2 times minus 36 is minus 72. And we're going to look at the coefficient of the x, minus 21, and we're going to look at the same two numbers need to add together to make that minus 21. So what we can do is we can write out the factors of minus 72, add all of them together to find out which one adds together to make that minus 21, or we can kind of do it in our head. So I'm thinking it's going to be 3 and minus 24. Let's just check that. 3 times minus 24 is minus 72. 3 plus minus 24 is minus 21, so that's correct. I'm going to write out this expression. Won't worry about the equation later. But instead of minus 21, I'm going to write plus 3x minus 24x. So I'm just going to replace it for what we've just found out. So it's going to be plus 3x minus 24x minus 36. And we might find it easier if we put the negative first, and I probably should have put the negative first, but let's keep going just in case we don't put the negative first. And we're going to do both of these separately. First two terms and second two terms separately. So we're going to factorise them linearly. So I'm going to take the x out of both of these, or divide the x out of both of these. Now here, don't forget the minus needs to be on the outside. So we've got minus, and it's going to be 12. And that's going to be 2x, and that's going to be a positive because it becomes a negative. Positive 3. The repeating bracket is one of our brackets, and then the bit left over, so the x minus 12 is our other bracket. So it's x minus 12 and 2x plus 3. To solve now, we get both of the brackets equal to 0, so x minus 12 equals 0. Get our lines in. And we're going to add 12 to both sides. So we've got x equals 12. That would be our first solution. And then we do exactly the same thing for the other bracket. So 2x plus 3 equals 0. Get it equal to 0 and solve it. And so we're going to take away the 3 both sides first of all. So we've got 2x equals minus 3. And then we're going to divide by the 2 both sides. So we've got x equals, and we can write it as a fraction, minus 3 over 2, or 1.5. And there we go. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is, and that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed, and all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'd be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now, so it's y equals 3,430 over x cubed. And that actually is our answer. So we know that the frequency density is proportional to the frequency over class width. And looking at this first group, we've got a frequency of 2, so it'd be 2 over, and our class width is 10 because it's 0 to 10. And so the frequency density is proportional to 0.2. Now, if you look at it, it's actually 0.4 in our graph. So to work out the equation, I'm going to do frequency density divided by class width. And you notice that we've then had to times it by 2. Okay, because it was 0.2 and then it's shown as 0.4 in our graph. So we're going to use that formula to find out the frequency densities for the others. Well, actually, we've got the frequency densities. We're going to be working out what the frequencies are. So the frequency density is 2.2 for the next one. It's 2.2 equals, and the frequency is what we're looking for, so we'll just call that x. The class width is 10, and we're timesing it by 2. And so when we can divide by 2 both sides, 1.1, then times by 10, that would be 11. And so that frequency is going to be 11. And for the next one, it has a frequency density of, is that 1.6? So it'd be 1.6 equals, and we'll just call this x as well, over, it's not 10, it's going to be 5, times 2. And we're going to divide both sides by 2, that would be 0.8 on the left, and then times by 5, and that will give us 4. So our frequency is going to be 11 and 4. So the frequency is kind of equal to the frequency density times the class width. And I say kind of because it's actually a proportional relationship. The frequency density doesn't have to be that value, it can be twice the value or half the value. But we're going to assume it is because we can check whether it is by the value given to us in the question. So going through each of the groups, the first one is 0 to 10 and it has a frequency density of 0.2. So we're just going to do 0.2 times 10, which will be 2. The next one has a width of 20 and the frequency density goes up to 0.8. So 0.8 times 20 will be 16. And the last one is a class width of 20 and it goes up to 1.2. So we're going to say that that frequency is 24. So if you do 24 plus 16 plus 2, you actually do get to 42. So we know that that is frequency equals frequency density times class width. Okay, now it says to estimate the amount of rocks that were greater than 15 kilograms. So we're going to draw a line up from 15 kilograms. And we're looking for all the values that were to the right of that line. So we know that there are 24 definitely, okay, because all of that bar is to the right of that line. And we've just got to work out what proportion of this bar is to the right of that line. Well, it's 4 squares wide and we're looking at 3 of the squares. So it's going to be 3/4 of 16. So the amount we're looking for, so rocks, is going to be 3/4 of the 16 plus the 24. So the 3/4 of the 16 will be 12 plus the 24, which will be 36. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. When we multiply two surds together, so here we've got root 6 and we're timesing it by root 7, we can actually just multiply the numbers together, so that becomes root 42. And so our answer will be root 42. Okay, so we're just expanding this similar to when we expand a quadratic double bracket. And so you can choose any method you want. I'm just going to choose the grid method. But it doesn't really matter. You pick a method you're comfortable with. So we've got 4 root 7. And we've got 9 and then minus root 7. So we're going to do 9 times 4, which is 36. 9 times root 7, which is just 9 root 7. 4 times minus root 7, so that'd be minus 4 root 7. And then minus and a positive make them negative. And then root 7 times root 7 is just going to be root 49 because you times together the number inside the surd. And then root 49 is just 7, so that's just going to be minus 7. Then we can add these two together, which will give us 29. And then we can add the surds. So actually it's going to be taking away because we've got minus 4 root 7 there. So 9 root 7 take away 4 root 7 is going to be plus 5 root 7. Compare it to the question, a plus b root 7. The a would be 29 and the b would be 5. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1 minus 1, so it's this one is the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. that would be what would be tempting to do. But when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times the top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. I'm going to start off this question by factorising the denominator of the first fraction. And so we've got 1 over... I'm going to factorise it. Now if you want to see how to factorise it, you can see other videos we've got. I'm kind of assuming you know how to factorise this if you're watching this video. And just keep the second fraction the same. Now you can't add fractions unless you have the same denominator. So if you look at the first denominator, the only difference between the first and the second is that 8x plus 3. So I'm going to times top and bottom of the second fraction by 8x plus 3. Now it helps us to remember that, you know, technically that bottom expression, the x plus 2, is in brackets. So I'm going to just copy down the same first fraction because we're not really doing anything with that. And what I'm going to do is just times top and bottom by the 8x plus 3. 1 times 8x plus 3 is just 8x plus 3. And that should do it neatly. And we've got the 8x plus 3 times the bottom, which will just give us the same denominator. So now the denominators are the same, we can just add the numerators. So it's just going to be 1 plus 8x plus 3, or in other words, it's going to be 8x plus 4. So it's 8x plus 4. And the bottom one is going to be 8x plus 3 and x plus 2. So we're going to just quickly write out our sequence. So 9, 22, 41, 66 and 97. And we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences, and so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence, and we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared, so we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3. 3 times 2 squared, which will be 12. And then 3 times 3 squared, 27. 3 times 4 squared, 48. 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. So at the point on the graph where x is 12, it's this point here. And what you need is a ruler. And what you're going to do is rest it on so it becomes the tangent of that point. So I'm going to try my best to do it here. I'm just going to draw it out, and this is going to be my ruler. And I'm just going to move this into place. So we want that to be a tangent at x equals 12, which is about here. And then what you do is work out what the gradient of that line is. So I'm just going to draw a line across and up. And we know that gradient is the change in y over change in x. The change in y is 2, and the change in x is 1. 2 divided by 1 is just 2. So the gradient at x equals 12 is 2. Now notice it says x equals 12. It's a curve, so the gradient's constantly changing, but an estimate of the gradient at that point is roughly 2. And you just need to make sure you rest the ruler down, and then until you're happy with it, draw the line like I've done with the blue line, and then just work out the gradient of that. And if you just show all your workings, show the examiner how you've come up with the value, even if your gradient's slightly off, you might still even be able to get full marks on some of the papers, if not 1 out of the 2 marks maybe. So we're told to complete the square, so we're just going to get this equation here and just complete the square for it. So the first thing I'm going to do is remove the coefficient of the x squared. So we want just x squared and so on. So I'm just going to make a set of brackets, and we're going to factorise it out of the x squared and the minus 24x, so that would be minus 8x. Then we've got the take away 15. Next I'm going to complete the square, so I'm going to do this in a different colour just so we can see what's happening. And to do this, we have a bracket with an x minus half of the coefficient of the x. So that'd be 4 squared. Now if we expand that, we get x squared, brilliant, minus 8x, fantastic. And then we have a plus 16, so we need to remove the 16. So we're going to take away the 16. Next we're going to expand the bracket with the 3 in. So we're going to have 3 brackets x minus 4 squared, or close bracket squared, minus 48, minus 15, and then we're just going to tidy that up by adding the numbers together, so that would be minus 63. On our graph, we're going to draw the graph of y equals 3x squared. Okay, simple. And we don't need to, it's only a sketch, so we don't need to worry about exact values, but we do know the most important thing is we know it goes through the origin, so it hits here at 0, 0. That's the important thing, okay? Because we know that if we called that f of x, then the situation we've got here, well, it's going to be f of x minus 4, okay, because we've got the minus 4 there. So that means it will move to the right 4. Okay. And it will also, we've got to worry about that minus 63 as well. And if we had f of x minus 63, we know it goes down 63. So in total, we have f of x minus 4 take away 63. That's what we have in total. So we're moving just 4 to the right and then 63 down. So instead of 0, 0, our minimum point will be at 4 minus 63. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.